So for my first video, I'm going to be explaining the difference between symmetry elements and symmetry operations, what the different symmetry operations are, and how they differ from one another. So we'll start off with symmetry element. Basically, all this is the parts surrounding a object that signify whether or what kind of operation must be done to the specific molecule. These can include, sorry about that. These can include a point, and this basically goes with inversion center, which is a symmetry operation. There's a lines too. This has to do with rotational axes and mirror planes. And this has to, and yeah, I think this one is just self-explanatory. With inversions, when you want to signify that inversion center is there, you use I. When you use it for a rotational axis, usually C is used. However, if it's improper, which we'll get into, S is usually used. And a mirror plane, sigma is used for to signify this. And the sigma can either show that the mirror plane is vertical, horizontal, or even, in some cases, dihedral. And yeah, the same can be done here with an N for the rotational axis, same for an improper rotation. So I'll start off with the rotational axis because that seems to be easiest. Let's say we have a trigonal planar molecule. Now, if we look here, we know that the angle between all the fluorines is about 120 degrees. When describing a rotational axis, this is pronounced as C3. And there are 3 different planes of rotation with BF3. Or 2, rather, sorry. So we would call this C3, 2, the 2 signifying that there are 2 different ways to rotate this around. Now, because this has the highest value, we call this the principal axis. When I say highest value, it's the highest number of rotations can be made with this. This is just one example. There's also a mirror plane. Essentially what this is it's a reflection through the molecule. A good example of this would be with water. And the plane, of course, as we know, going through the middle in this oxygen. When we flip it around, we know that there's going to be a hydrogen on this side as well. They can go back and forth, flipping between these two. And this shows us just that there's a mirror plane in the middle. And if we wanted to specify this, obviously, like from up here, we use sigma. And also the fact that it's going through the plane, going down vertical, we use V as a subscript. So again, the symmetry operation is that this is a mirror plane, and it's also the same with the fact that it's a symmetry element. Second to last, we also have inversions. Basically, what an inversion is it shows that, well, I'll just show you an example right here. So say we have sulfur with 6 fluorines attached. What an inversion center shows is that if you flip from one molecule to the next, they'll show up on the same side. So the inversion center for sulfur is right here. If you flip it around, fluorine goes to fluorine, this fluorine go here, and this fluorine would go here. Inverting all of these, you get the exact same molecule. It means you're given the ability to invert between these different fluorines altogether. And to specify this, we'd give it I, just to show that, yeah, this can be inverted. And we have one more to get through, and that is with, say, an improper rotational axis. A good example of this would probably be with methane. So, give me 1 second here. So say we have a methane molecule here. Two of these going out. We have one going behind, one in front. So basically what an improper rotation shows that we're able to rotate this molecule, but it also has to include a fold or a reflection almost through it. So I'll show you here. Say we rotate this about 90 degrees. We have this as a result. And we do one more step where, in this case, we do a reflection. And this reflection, of course, exists here, horizontally. And this gives us, essentially, the same molecule as we had at the beginning. And because this is tetrahedral, we'll give it an S for improper and a 4 through it because it's tetrahedral. And this is just one of many examples, other examples that could be used to explain this, but I feel as though methane's the most simple. Yeah, that's about all I have. Hopefully that was a bit clear on, hopefully I made it a bit clear about what all these different rotations mean, what they mean for, obviously, inorganic chemistry, and how we can use it. Yeah.